This is pi. Hello. Pi is very special. Pi is special because it is the 16th letter in the Greek alphabet. So it's like P or Q, but in Greek. But pi is even more special because, believe it or not, it is actually a number. Yes, it may not look like a number, but it is an actual number. In fact, it is a very special number. It is a constant. So, what is a constant? Well, constant is a number that stays the same no matter where, no matter when. So, for example, your age would not be a constant because as you grow from a baby to a child to an adult, your age does not stay the same. So, your age is not a constant. But the sum of three angles in a triangle, on the other hand, is a constant. That means that no matter whether you draw a big triangle or a small triangle, whether you've drawn it in your room or on your sister's face, it is always going to be the same, 180 degrees. Now, it just so happens that if you draw a circle with a diameter and the circumference, the ratio between the diameter and the circumference is a constant, and it is equal to pi. That means that no matter whether you're on Earth or on Mars, whether you're making big circles or little tiny ones, if you divide the length of the circumference with the diameter, you will always get pi. Well, isn't pi special? But what exactly is the value of pi? Well, pi equals to 3.1415926 blah blah blah, etc., etc., etc. Pi actually have an infinite number of decimal places. It just goes on and on. No one knows the exact value of pi. We can only estimate it with an approximation that gets closer and closer to what it really is. So how can we estimate the value of pi? The easiest way would be to draw a circle. Then take a ruler, measure the diameter, and then we can take a string, make it go around the circle, and then measure that to see what the circumference is. Then you can divide the two numbers together to get pi. Simple, isn't it? In fact, why don't you try it and leave a message in the comment section below to tell me what you have measured. If you did do the experiment, did you notice a problem? It is very hard to be very accurate in measuring a piece of string. Maybe it's not straight, maybe it didn't go around the circle exactly, or maybe you're just very clumsy in measuring. Is there a better way to estimate pi? Well, guess what? Mr. Archimedes is way ahead of you. 2,300 years ahead of you, in fact. Archimedes, the great ancient Greek mathematician, have come up with a method called the method of exhaustion. And it goes something like this. Let's first start with a circle with a diameter of 1. Since pi equals to the circumference divided by the diameter, with a diameter of 1, the circumference is simply pi. So all we need to do is find out what the circumference of the circle is to know pi. Next, we draw a polygon, say a hexagon, inside the circle so that the vertices are touching the circle like this. We also draw another polygon, say a square, outside and touching the circle like this. Then, if we look at this picture, we see that the circumference of the circle, or pi, must be equal or must be between the perimeter of the inner hexagon and the perimeter of the outer square. So we have just determined a range for pi, that the value of pi must be between these two numbers. These are called its boundaries. Anyways, we can now find the parameters of the square and the hexagon to find these two boundaries of pi. The parameter of the square is pretty easy. The side of the square equals the diameter of the circle, which is 1. Therefore, the parameter is 1 plus 1 plus 1 plus 1 equals 4. The hexagon is slightly trickier. We first start by drawing a line from the center of the circle to one of the vertices. The length of this line would be the radius of the circle, which is half. We can do this many times and draw 6 circles. And each of them is the same as each other. Since we are dividing the full circle, which is 360 degrees, into 6 parts, each of these angles in the middle is 60 degrees. But we also know that the two sides of the triangles are the same. They are both the radius of the circle. This means that these two angles on these sides are also 60 degrees, since the sum of the 3 angles are 180 degrees. With these 3 equal angles, this is telling us that this is in fact an equilateral triangle, and this third side is the same as the other 2 sides and equal to half. And so the parameter of the hexagon is simply half repeated 6 times, giving us a parameter of 3. So we've now determined that pi sits between 3 and 4. Now that's not a very good estimate of pi, is it? But we can get closer and closer to pi by increasing the number of sides of each of the polygons. If we start, for example, with hexagons on both the inside and out, we can find pi to be between 3 and 3.46, slightly better than using a square outside. If we now double it and use a 12-sided dodecagon, which look much closer than a circle, we get pi between 3.105 and 3.215. We can keep on doubling this and get closer and closer to a true circle. In fact, Archimedes has used 2 96-sided polygons and calculated their parameters to estimate the value of pi to be between 3.14103 and 3.14271. If you think that is extreme, a Chinese mathematician, Zhu Congzi, used 2 24,576-sided polygons to estimate pi to be between 3.1415926 and 3.1415927. This was the best estimate of pi for over 1,000 years. Now that is extreme. But you might say, well, I can't even draw anything beyond an octagon, let alone a 96-sided polygon. And how do you find the parameter of a 96-sided polygon anyway? How about I let you know a different way of finding pi, and all you need is just a cardboard and some darts. First, you want to cut a square out from your cardboard. That is your dartboard. Next, draw a circle inside like this. Then the square would have a side length the same as the diameter, or twice the radius, 2r. This means that the area of the dartboard is 2r times 2r equals 4r squared. The area of the circle, we know, is pi r squared. You can imagine that if you're throwing a dart at this randomly, your dart may hit inside the circle or outside the circle. And the chance of the dart hitting the circle depends on the area of the circle. The bigger the circle, the easier to hit, right? In fact, the chance of a dart landing inside the circle is equal to the area enclosed by the circle divided by the area of the dartboard. which is pi r squared over 4r squared, giving you pi over 4. This means that if we hang this board on the wall, and you can start throwing darts at it at random, you can also lay this on the floor and drop pins onto it if you don't have darts, but the important thing is blindfold yourself so that where it lands is completely random. Then we can take a tally of how many darts that lands inside the circle, and at the end of the experiment, we take this number and divide it with the total number of darts that did land on the board. We're not going to count the ones that missed and hit your brother's butt. And if we time that result by 4, we should get pi. Elegant, isn't it? No need for angles or trigonometries or whatnot. Throw some darts and you shall get pi. There's a catch. You have to be very, very patient because there's an element of chance here. So when you say, if you throw 10 darts, you might get something like this. Something close to pi, but not quite. You can get closer by throwing more and more darts. 100 darts, 1,000 darts, and if you're really bored, 10,000 darts. We can get quite close to pi, but not that close. That's because it is random, chances in play. Just like in the die, you're not guaranteed to get a 6 every 6 turns. You're also not guaranteed to land in the circle every fixed number of dart throws. And so the answer you get will always be random, close to pi but not quite. A way to get even closer is to get a few friends who are also very bored and let them each throw 10,000 darts. And then you can take all their results and average it out, because averaging tends to cancel the randomness away and leaving you something that is relatively close to pi. Very simple. So there you are. 3 different ways to find pi. In fact, there are many more interesting ways to find pi. If you want to know more, hit the like and subscribe button below, and with enough likes, I just might go over some more interesting way of finding pi. I'm William, and this is Beyond Infinity. See you again in the next video.